Hi class, let's take a look at example 5, and here's the main objective in example 5. They want us to express it as a rectangular equation and then use this rectangular equation to find the area under the curve. It may just be easier to evaluate some of the functions in that form. But let's take a look at this one, and they're expressing it as e at t. You still have x is equal to technically t squared, y is equal to t to the third, and the most important part for the rectangular equation is the actual domain. So if you were to take the square root of this one, you would end up with technically, t, in this case, t is equal to plus or minus the square root of t. And if we were to evaluate into y, this is equal to this is supposed to be an x, so we're looking at this one is just an x value, and then the square root of x evaluated to the third power, so this is x to the 1/2 raised to the third, or x to the 3/2. Since they're asking for under the curve, it's just going to be the positive value for this one. So your y value, it's going to be just the x to the 3/2. Wait, I'm making it worse. So the sketch of this one, it's simply going to be in 3/2 has this sort of shape going in this direction. Okay, so the actual x values that we're looking at, so when t is equal to 0, your x is equal to 0 and your y is equal to 0. So you're integrating from 0, and well, this one is just going to be 0 to 1, but let me rewrite it. T is equal to 1, x is equal to 1, y is equal to 1. So technically from here. So this is the region that we're going to be actually looking at. Now, as we actually look at the area under the curve, so area under the curve, this is equal to the integral from 0 to 1 of technically x to the 3/2 dx. Now, if they actually meant for us to get the negative of it, they would have provided us with a sketch, but in this case, under the curve just means you have the y is equal to 0, technically lower bound for the functions. Okay, so in this case for this one, that's pretty much it. This is going to be x to the 3/2 plus 1 divided by 3/2 plus 1, evaluated from 0 to 1. So we're just going to be evaluating x to the 5/2 divided by 5/2 from 0 to 1, or 2/5 of x to the 5/2 from 0 to 1, which is just going to be 2/5 times 1 minus 0. We're looking at 2/5. So the area under the curve is equal to, 2/5 units to the second power. And that's actually it for this one.